Infinite Limits Part 2. I promised you at the end of Part 1 that we would find a limit by using our reasoning skills. Notice that the value x equals 3 makes the denominator 0 and the numerator non-zero. So there is a vertical asymptote at x equals 3. Let's repeat that. Non-zero over 0 means you have a vertical asymptote. I do want to point out to you that if you have 0 over 0, it might be a vertical asymptote or it might not. To know that you have a vertical asymptote, it has to be non-zero over 0. All right. So if I have a vertical asymptote at 3, then as x approaches 3, from the right or from the left, I know that my answer will be either infinity or negative infinity. So the question becomes, which is it? Will it be positive infinity or negative infinity? Well, the numerator is positive. The denominator is positive for x larger than 3. Now x is larger than 3 because x is approaching 3 from the right. So my numerator is positive, my denominator is positive, and so the expression is positive. For that reason, my answer is positive infinity. Let's do that again. Let's do the same problem, but this time let's approach 3 from the left. Again, the value 3 makes the denominator 0 and the numerator non-zero, so there is a vertical asymptote. Non-zero over 0 means you have a vertical asymptote. If you have a vertical asymptote, the answer is either positive infinity or negative infinity. The numerator is positive. This time the denominator is negative. Now why is that? If x is approaching 3 from the left, that means that x is always less than 3. So it would be something like 2.9 or 2.99 or 2.999. Take 2.999 and subtract 3. Don't you get a negative number? Yeah, so the denominator is always negative. So I'll have a positive numerator, a negative denominator, and the overall ratio will always be negative. So I know my answer is negative infinity. And you can see these two answers by graphing. Find the limit of tangent x as x approaches pi over 2. Probably the easiest way is to just sketch yourself a graph of tangent. Where does tangent have its asymptotes? Is there an asymptote at pi over 2? Yes, tangent does have an asymptote at pi over 2. And as x approaches pi over 2 from the right, the graph is headed downward. And so the answer is negative infinity. What about coming from the left? Well, coming from the left, the graph is headed upward. And so the limit of tangent as x approaches pi over 2 from the left, that limit is positive infinity. Now, coming from the left, I get positive infinity. Coming from the right, I get negative infinity. So the limit of tangent as x approaches pi over 2, it does not exist. You can't say it's infinity, you can't say it's negative infinity, because depending on which direction you come from, you're going to get a different answer. So you would say the limit does not exist. All right, I would like to, before I leave you, I'd like to give you a little warning. You need to know where your asymptotes are, right, to do this. So what about cotangent as x approaches pi over 2? Well, cotangent does not have an asymptote at pi over 2. And why is that? Well, cotangent is cosine over sine, and sine of pi over 2 is just equal to 1. So I don't have an asymptote, and in fact, my function in this case can be found, the limit can be found by direct evaluation, because I can do a direct evaluation for cosine, I can do a direct evaluation for sine. I do not end up with 0 in my denominator. And when I do a direct evaluation, I get 0 over 1, which is equal to 1. So when you do this, keep in mind that your answer will only be infinity or negative infinity if you have a vertical asymptote. And this function does not have a vertical asymptote at pi over 2. Take care and have a great day.